So we're continuing here. So we got our even and odd proofs. We got divisibility tests that'll be on our exam 3. And remember, we're looking to show work on those. What else? What else we have on exam 3? Primes, okay, prime numbers. Okay. So things to know about this. Prime testing. So for example, is 257 a prime? Okay. That number, I might ask you whether it's prime. Okay, now, how do we know when to stop? Okay, right. So we need to estimate this number right here, 257. I need an estimate for this. Okay, now think about the squares. Remember, we talked about memorizing the squares for things like 12, 13, 14, 15, 16, 17. Okay, what's 15 squared? 225. What's 16 squared? 256. Okay, so I don't know what square root of 257 actually is, but I know it's bigger than 16 and it's got to be less than 17 because 17 squared is 289. So these are the numbers I should test. If we're asking, is 257 a prime? I should test, is it divisible by 2, 3, 5, 7, 11, and 13? Okay. Why didn't I test 17? 17 is a prime. Right, we're testing stuff up to whatever this is, and we know this number is less than 17, so 17 is beyond the cutoff. We don't need to test it. If this thing is divisible by one of these primes, then it'll show up here. Okay, so be ready for prime testing. Review the proof that there are infinitely many primes. Okay, review that proof. I will put it on the test, so be ready for it. Okay, we also had material about the GCF and LCM. Okay, so give me an example. What might I ask you about this topic? It's a pretty easy one to come up with examples for. Right, I give you two numbers and say, give me GCF of, I don't know, 48 and 63 or something like that, okay? Now, I do have a couple of things I could ask you. I do have a couple of ways I could ask you to do it. I could say, find GCF of 48 and 63. What else can I say? Find GCF of 48 and 63. Right. We have two different methods. So I could just ask you the question and say, find GCF of 48 and 63, and you do it using whatever method you like. Or I might say using the Euclidean algorithm or using the prime factor method. In those cases, I would expect you to use the specified method to get full credit there, okay? So keep that in mind. Okay, what else? Okay, all the stuff we've been doing with fractions, okay, so the operations with fractions. The different models we have for doing those operations and for creating fractions and mixed numbers. And also, of course, word problems. That involve fractions and writing teachers' solutions to those word problems. Okay, if you look at the last quiz, there were, what were there, 4 questions on that quiz? How many word problems? 2, okay, so I'm expecting at least 2 word problems on this test, okay? In fact, probably even more, because let's look at our table of contents here, right? In chapter 6, I've got elementary math for teachers open here. In chapter 6, 6.1, fraction basics. Okay, so that was where we were taking an object and splitting it into so many pieces and then shading a certain number of pieces to demonstrate what a fraction was representing. And then we had more fraction basics, stuff about like adding fractions and things like that. Multiplication and division of fractions. And we got a whole section here, division word problems. Okay, so between today and Friday, we're going to work on those division word problems. Okay, so since there's a whole section in the book devoted to that, there's probably going to be ready for more than one word problem to be the main bullet point there. Okay. So remember, studying in this class means 1, figure out the types of things that I'm going to ask you on a test or a quiz. Okay, so we just went over that. So you know the types of topics I'm going to ask you. What's the next step? One more time? Okay, going over your quizzes. That'll give you another pass at the types of questions that I'm going to ask you, and also make sure you know how to answer those questions, okay? If you know that I'm going to ask you about the proof that there are infinitely many prime numbers, but you don't know the proof, well, you haven't really taken advantage of that fact, right? So if you know I'm going to ask you about that proof, make sure you study that proof and you know how to write it. If you know I'm going to ask you how to find the GCF using the prime factor method, make sure that you know how to find the GCF using the prime factor method. Okay, so now that we got that, let's get back to business here. Anybody have any questions over 6.3, the homework on 6.3, which is on page 149? Or anybody have any questions further back?
Did you go over some of the ones at 6.3 on number 11? I think I need a refresher on some of the
Okay, so if you've got your books here, we're looking at elementary math for teachers. We're on page 149. It says, identify whether the following problems use measurement division or partitive division. Okay, so let me do a couple of examples here. So page 149, let me do 11A. Okay, so it takes half a yard of material to make an apron. How many aprons can be made with 3 yards of material? Okay, so let me rephrase it this way. 3 yards is how many half yards, right? That's what this is asking. I got 3 yards worth of material. How many aprons can I make? So, and it also says, when in doubt, draw a picture. So my picture is like this. My whole bar represents 3 yards. And I'm breaking this up into pieces. Do I know how big the pieces are? So if I'm answering this question, 3 yards is how many half yards? Right, each piece is half a yard, right? So I'm breaking this up into pieces. That's half a yard. The question is, how many pieces will I have? All right. So that tells us whether we're dealing with measurement or partitive division. Which one do we have? Measurement. Okay. We know how big the pieces are. The pieces are all half a yard. We want to know how many pieces there are. Okay, let's do another one. Let me look at 11D. Okay, so the question reads, Mary poured 6 cups of juice equally into 8 glasses. How much was in each glass? So I'm going to jump right to the picture here. All right, so here's my picture. What does this whole bar represent? Right, 6 cups of juice. That was the entire quantity she's dealing with, 6 cups of juice. How many pieces am I going to break this up into? Or how big are the pieces that I'm going to break it up into? Which do I know? We know how many. How many pieces? So what should I do? I break it up into how many pieces? 8 pieces, okay? So 1, 2, 3, 4, 5, 6, 7 breaks. Now the question is, how big is that? So we're answering how big are the pieces? So what kind of division are we looking at? Partitive, right? Okay, so sometimes I find it helpful to rephrase in a question like this. 3 yards is how many, and you might say how many groups of 1/2. For this one, we might say something like 6 cups is 8 groups of what? Okay, so notice the difference. Here we knew the size of the pieces, and we're asking how many pieces are there. Here we know how many pieces there are, we're asking how big they are. Okay, so that is the difference between measurement and partitive division. Okay. So I'll leave the rest for you to work out there. Okay, any other questions from that problem set?
Can you do
7 and 9. Okay, now I don't think 7 was assigned, was it?
Oh.
I think it was 1 to 6 and then 8 to 11, if I'm not mistaken. Did somebody have that? Somebody check that? Okay. Okay, so don't worry about 7 basically. Now let's look at 9. Okay. So read the paragraph, anticipating, detecting, and correcting errors in the preface of this book. One common error is for students to write this. Okay, now how did the student get this?
They obviously multiplied the bottom.
Okay, so they multiply the bottom, so 1/12, where's that coming from? Right, the 4 and the 3. So they got the 1/12 by taking 1/4 and 1/3 and multiply them together. And how did they get this 2? by multiplying the 2 times the 1. Okay, so what this student did was they took the 2 times the 1, and they multiplied those, and they took the 1/4 and the 1/3, and they multiplied those. Okay, now, if I am doing addition of fractions, that actually works. If this were 2 1/4 plus 1 1/3, I could add the whole numbers and then add the fractions. Okay? But the question is, does this give the right answer here in this case? Okay, so it says, give an area model and a brief explanation which simultaneously shows both the error this student is making and what the correct solution is. Okay. So help me out here. How can I build an area model for this? When we're talking about multiplying fractions, how do we build our area models? Okay, right. So we had those rectangles and we're carving them up into pieces. Okay. Now, when I'm thinking about 2 1/4, what should I be doing there? So we're looking at problem number 9. We're talking about an area model for 2 1/4 times 1 1/3. Okay. So help me out here with this area model for 2 1/4. What do you think I should do?
You can make 3 columns, each split into 4 pieces, and fully color in 2 of them, and color in 1 piece of the 4 1/3.
Okay, right. Maybe we could try that. We could do 3 columns, 2 of them fully colored in, and then 1 of them is 1/4 colored in. Now, when we had that kind of model for fractions, didn't it go something like this? Like if I was going to do 2/3 times 1/4, I would go, okay, 1, 2, and then I would shade in 2 of those. And then I would do 1, 2, 3, 4, and I would shade in 1 of these. So I look at the boxes that are double shaded here. So I have 2 boxes that are double shaded out of 12 total boxes, and then of course we can reduce that to 1/6. Okay. So this area model, we might want to do something kind of like that. One thing I would note here. One 1/3 is bigger than 1, right? Because you have more, right? You have 1 and then you have extra stuff, okay? So 2 1/4 times 1 1/3, that should be bigger than 2 1/4 times 1. In other words, it should be bigger than 2 1/4. Okay, now look at the answer that student got. What answer did they get? 2 1/12. Is that bigger? Is 1/12 bigger than 1/4? Okay, no, right? 1/4 is bigger than 1/12. Okay, so but 2 1/12 is less than 2 1/4. Okay, so that's one way to show that student, hey, your answer isn't isn't doing the job that it's supposed to do. The answer that we get should be more than what we started with. Okay. So what we might do, okay, I'm going to go back on what I said a second ago about your answer, Victoria. We'll use that. Okay, we'll start with this. What did you say? You wanted 3 pieces, right? Okay, so 1, 2, and then 3. So shade in this, shade in this. And now do I do the whole thing? Okay, so I should cut this into 4 pieces and shade in 1. Okay, so that's going to represent 2 1/4. Okay. Now, here's what I'm thinking. Okay, so 2 1/4 times 1 1/3. This should be 2 1/4 plus 1/3 of 2 1/4. Okay. So where am I getting this thing where we're adding? What's happening here? This is multiplying, not adding. Why would I be adding?
Because the one doesn't change so much.
Right, that's part of it. That's this. You had something, Tori? Go ahead. Right. Yeah, multiplying it by the 1, which gives me that. Multiplying the 2 1/4 by the 1. And over here, I'm doing this. Okay, because remember, this is 1 and 1/3. We say it like that, but it's really 1 plus 1/3. You have the 1 plus you have an additional 1/3. Okay, so what we can do is we can take this and we can distribute it here. Okay, so we can have 1/3 of this right here and then 1/3 of this, in addition to what we already got, to what we have with this. So take that area model and then throw in, so we got that right there. Down here, let's do an area model for 1/3 of 2 1/4. How could we do that? Okay, split this into 3 pieces. Now, we got to be a little bit careful because I would probably do something like this here. So, 1, 2, 3. Okay, now I had that thing fully shaded. Okay, so that's what I got fully shaded right there. Now, splitting this into 3 is a little tricky, okay? Because 2 1/4, we got to remember that represents 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 quarters. Okay. You might do something like this. I know you're saying, okay, that's a lot of pieces. I broke each of the pieces into thirds. And I'm going to take one of those pieces. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9 over 12. Which is equal to 3/4. Okay. So a little tricky because of the mixed number business. Okay, don't worry too much about it. I won't put that one on the test. Okay, so that was number 9. And this is all from page 149 here. Okay, make sure you can do the stuff from Primary Math 5A though, okay? That's gonna make an appearance. Okay. So any questions on page 154?
Can you do a couple from number 2?
Okay. Illustrate the following with a bar diagram and solve the problem. Okay. So we're on page 154. And we're looking at problems from number 2. Okay, let's do 2B first. All right, now, if you haven't gotten a chance to look at the module for 6.4, make sure you go and do that, okay? So I got a complete set of notes for 6.4 up there. So let's think about this. We're looking at measurement. I'll just abbreviate here if that's okay with you. MD, measurement division, for 3/2 divided by 1/6. Okay, so this is the whole length that we're dealing with. We're taking that and we're breaking it up. So the whole length is represented by 3/2. Now, when we're dealing with measurement division, do I know how many pieces I have, or do I know the size of the pieces? We know the size, okay? So that's 1/6, and then the question is, how many pieces are there? Okay? So we have a whole length that is 3/2. And we want to know how many 1/6 are there in 3/2. So, oh, and I think they actually said solve the problem, right? So to do the problem, we do 3/2 times 6/1, and that works out to be 9. Okay? But let's come up with an interpretive question. Okay, now this is kind of a guide question. How many 1/6 are there in 3/2? Okay, that's not really what I would consider a word problem, at least not yet. But let's see if we can come up with one. Okay, so let's say we have something like this. we have 3 halves of a gallon of juice. Now, does this make sense to say we have something like this? What is 3 halves? 1 1/2. Okay, does it make sense to have 1 1/2 gallons of juice?
Normally, I mean, in my head, I'm just thinking of having a gallon and then having like another gallon that's halfway full.
Right, so let's say we have 2 1-gallon jugs. One of them is completely full, the other one is half full, right? So we have 3 halves of a gallon, 1 1/2 gallons. Okay, so yeah, it does make sense to talk about a situation like that. We have 3 halves of a gallon. Okay, now situations like this would be, there are other situations like we have 3 halves boys. Well, that doesn't really work, right? Because 1 boy and then half a boy, that's not gonna really work. But something like this that can be divided into any unit that we want. You have a gallon, you can cut that up in any number of pieces that you want by pouring it into the appropriate container. Okay, so this does make sense. We have 3 halves of a gallon of juice. Each thermos can hold 1/6 of a gallon. How many thermoses can we fill? Question mark. Okay, so there's a word problem that leads to this. We have 3 halves of a gallon. We're breaking that up into pieces. Each piece is 1/6 of a gallon. We want to know how many of these we can make. So that leads us to how many 1/6 are there in 3 halves, and then we do the division to solve the problem, and we get that there are 9. So we can fill 9 thermoses if they each hold 1/6 of a gallon. Okay, let's do let's do part C, 2C. Okay, so this is about partitive division. For 14 divided by 4. Okay, so I'm starting with my picture. There's my picture. Okay, now what do I do with this? Okay, break it into 4 sections because we're talking about partitive division. We don't know how big the parts are. We know how many there are. There are 4 of them. So the entire length represents 14. And we're breaking it up into 1, 2, 3, 4 equal pieces. And the question is, how big are the pieces? So give me an interpretive question that looks like this. Not a word problem just yet, but a question that looks like this for this division problem. So think about what this picture is indicating that we should do. We know we got 14 something, whatever it is.
All I can think of is like, how much can we fit into 4 pieces of 14? Like, that's kind of where my head's at, because I'm
Okay.
thinking about, like, how much can we fit in a box?
Right, right. So we might say 14 is 4 groups of what? Okay, so in other words, what fits in those equal boxes? Okay? So the process is 14 is 4 groups of what? Now make a word problem out of that. Describe a little situation, maybe one sentence to describe it, and then one question. One declarative sentence, one interrogative sentence.
We have 14 pies with 4 kids. How many pieces of pies?
Okay, right. So we have 14 now. So they could be pies, they could be whatever. We have 14 pies. 4 kids will share them equally. How much does each get? Okay, how much of a pie does each one get? Okay, now of course, when we do 14 divided by 4, that's equivalent to saying this, right? That's 14 over 4, which is equal to 7 over 2, which is equal to, nope, 3 1/2. Okay? So each kid gets 3 1/2 pies. Now, does that answer make sense? Can we do something like that? We got 14 pies. Sure, we could give a kid a half a pie. What do? Cut it into 2 equal pieces, right? So that answer makes sense. Okay, so we got a little word problem there. So if you haven't started this yet, make sure you do. We're working on page 154. The assignment here was all the problems 1 through 6. Okay. So for practice with the word problems, do the bar diagram, but also try to make up a question that would lead to this operation. Okay.
The partitive ones that have like 1/3, how would you break it into 1/3?
Okay. Right. So let's think about it with this interpretation here. So which one are you looking at there?
I'm looking at
D to
yeah.
D. Okay. So 2D. And the question was what? 2/5 divided by 1/3. Okay, so let's go to the question first. And we're talking about partitive division here. Okay, so we know the number of parts that we got.
Mhm.
So kind of our models here like this. So 2/5 is 1/3 So 2/5 is 1/3 of a group of what? Okay, now instead of the 2/5 being the whole thing,
Mhm.
I'm going to do this.
Oh, okay.
Okay,
Mhm.
so the 2/5 is not the whole thing. I've divided the whole thing into 3 pieces.
It's the 1/3.
Right, there's your
Okay.
1/3.
Okay, thank
Okay.
you.
I was just wondering if you can explain to me what you wanted on these fraction problems.
Okay, was that the picture one?
I reduced it, but I'm wondering if I
I know that it's just a trivial, something trivial. but I
Okay,
just wanted
right.
to
So
know
here's the thing
how I
with,
can
with
fix
both
it.
of these actually,
Yes, sir.
okay? So you're right that we do have, where are we on C? We do have 8 pieces,
Right.
but they are not all equal sized pieces,
Oh, okay.
okay? So notice if we took this little triangle over here and we put it up here, you would fill in one whole piece.
Okay.
So you actually have 1 out of 6 for part C.
Gotcha. Okay.
And
I
same
think
thing.
I just took it for granted.
Yeah, a lot of people did that. They said, okay, well, there's 3 pieces, 2 of them shaded
Gotcha.
2/3.
I was just wondering if I reduced it wrong or if I like
Yeah.
counted it wrong.
Yeah,
or
so that's the
something.
thing. It's the size of the piece that we need to take into account. Yeah,
The first one is this this right here, is this for the infinite?
right. So we assume that we do have a list and that the list stops.
Yeah.
And then we show that we can create a new number. Now, be careful. This is not exactly it. There's a part missing. You got to add 1 to that. Right, because there's no way this could be a prime because it's divisible by all these numbers.
Mm-hmm.
But when you add 1, well, now it's not divisible by anything on the list anymore.
So if I wrote that and then put +1.
Plus 1, that's the new
Okay.
number.
And then this, I didn't know why I got this one wrong, and I was supposed to ask you a while back. Because that was a question to the,
Ah, okay.
and I got it completely wrong, and I don't know.
Well, I think what you ended up doing was you were treating this as 3 separate numbers. You were treating it as 5,
Oh.
192. It's one big number, 5,192,132.
And then it was that a divisibility test?
Yeah, so you go through the
Okay.
divisibility test on that one big number.
Okay, and then I have this, because
Oh, do you have your,
yeah.
oh, okay, mental math quiz 5, okay. Okay, you folks in Zoom land, I'm gonna end the meeting. We're done for the day.